Let's solve some logarithm equations. We need to look at how to go about solving logarithm equations. If you are given log a base b equals x, this is an example of an equation. The first thing you have to do is to ensure that this side is transformed into logarithm. So to transform x into logarithm, you are going to apply the identity rule to x. So log a base b equals x log b base b. Now log b base b is 1, so it's the same as writing just x. So the reason why I'm applying b as the base here is because I'm giving b here as the base. So, and I know that when the number and the base are the same, then it's the same as 1. Now these are to transform x to logarithm, so the both side of the equation must be in log form. The next is to transfer x to become the exponent of b based on the power rule. So log a base b equals log b to the power of x base b. Now comparing these to the left hand side and the right hand side, we can see that a equals b to the power of x, a equals b to the power of x. So whenever you are given an equation such that on the left hand side of the equation and on the right hand side of the equation the base of the logs are the same, you can equate the expressions here or the numbers here as the same. Now, so let's solve this. Log x plus 1 base 3 equals 2. Just like we did before, this becomes log x plus 1 base 3 equals, transform 2 to log form, so 2 becomes 2 log 3 base 3 because this is the same as 1. Now log x plus 1 base 3 equals 3 to the power of 2 log 3 to the power of 2 base 3. Now since on the left hand side and on the right hand side the two logs are of the same base, I can equate the expression x plus 1 to 3 to the power of 2. So x plus 1 equals 9. 3 square is 9, and x equals 9 minus 1, x equals 8. Now the next one here is this: solve 1 over 2 log 64 base x equals 3. The same thing applies here, but before I transform 3 to log form, I need to bring 1 over 2 here to become the exponent of 64, going by the power rule. So 64 here becomes 64 to the power of 1 over 2 base x equals 3 log, so I'm using x here since the base I'm giving here is x, so x base x. Now 3 comes here to become the power of the exponent of x. So you are going to transform 1 over 2 here to square root, and this equals log x to the power of 3x. Now you can now equate these two together because they are now equals, since the log here is in base x and the log here too is in base x. So root 64 equals x to the power of 3. Root 64 is 8. Now to get your x, you are going to take the cube root of both sides, or you multiply both sides by the power of 1 over 3. 1 over 3, 1 over 3. So 3 cancels 3 here. You are left with x here. You have to find the cube root of 8. The cube root of 8 is 2, and your answer is 2. So x is 2. The next one, the same process applies here. 1 will be converted such that it has log in it. So this becomes log x plus 2. Going by the product rule, x plus 2 multiplies x minus 1 equals log. So what this will become log 10 base 10. Now log 10 base 10 because the base of the log here is 10. Whenever you are given a question in which the base is not specified, you assume 10 to be the base. So this log base 10, this log base 10. So because the base here is 10, I'm applying 10 here also as the base, and as you know that if the number of a log and its base are the same, the answer is 1. So you equate the numbers or the expressions. So x plus 2 multiplies x minus 1 and equals 10. When you expand this, you get x squared. This is minus x plus 2x minus 2 equals 10. Now x squared plus x minus 2 equals 10. You're going to subtract 10 from both sides. Finally, this gives us x squared plus x minus 12 equals 0. So you are going to factorize this. To factorize this, the two numbers you need to factorize this are 4 and 3. So plus 4 and minus 3. Now, so simply write x plus 4 times x minus 3 equals 0 as your factorization. So x plus 4 equals 0, or x minus 3 equals 0. So finally x equals minus 4, or x equals 3.